Hello friends. Um, there is a big mystery that how continents and oceans has originated. There are many theories who try to prove how the continents and oceans are developed. So today we will discuss about the plate tectonic theory. However, this plate tectonic theory was developed on the plate tectonic theory. This theory was developed on the concept of the continental drift theory and the various post-drift theories. And this theory tried to explain how the movement of the tectonic plate has taken place, what are the interactions that has taken place between the tectonic plates, and due to those interactions, what phenomena or geographical features formed on the Earth's surface. So before discussing about the plate tectonic theory, let's see what is being contributed by the post-drift theories and continental drift theory to this plate tectonic theory. So when we are talking about the the continental drift theory, since we are discussing about these theories in short, so that we can have a better idea, we can better understand what is plate tectonic theory. So the around 1930s, 1912, the Wagner gave the continental drift theory. So this theory, continental drift theory, this theory was proposed by the Alfred Wagner, and he collected some evidences from the land masses, and on the basis of those evidences, he believed that earlier these land masses were combined together into a single land mass, which later on drifted away from each other. So which are those evidences? So the first and the most important evidence was the matching of the shapes of the continents. Wagner matching of the shapes of the continent. Wagner observed that if you see the map of the South America, and if we see the map of the Africa, so we will found that this part of the South America will fix into this part of Africa. So this proves that earlier these two land masses were combined together into a single landmass, which later drifted away from each other. Then then second is age of the rocks. So Wagner observed that by the carbon dating method, he calculated the age of rocks and found that same age rocks are found in the different parts of the continents. So he assumed that it could be so that these rocks were formed at one place, later on get drifted away from each other. He also found the formation of the tillate. So Wagner, tillate is what? It is the glacial sediments deposition. So so it is an evidence of the polar regions, cold area, and he found this glacial evidences in the territorial region. So how in the tropical region we found these glacial evidence, how the formation of the tillites is occur in these tropical regions. So he found these tillite formations in the 6 major land masses: South America, Africa, peninsular India, Antarctica, and Australia, and the Falkland Islands. So these were the 6 land masses in which he found the tillite formations. So this makes him believe that earlier these 6 land masses were combined together into a single land mass, and later on they get drifted away from each other. So Wagner proposed that the horizontal movement of the tectonic plate has taken place. He also found the one more evidence of the fossils. The similar animals and the plants fossils were found in the rocks. Example, he found the fossil of the lemur in the India, peninsular India, as well as Africa and in the Madagascar. Now these three land masses are separated apart. So how the these lemur fossils are found in this rock? It means at that time these all land masses were combined into a single land mass. So this is what is being proposed by the Wagner. However, he was unsuccessful explaining the reason, what are the force that is mainly responsible for the movement of these tectonic plates. He says that the tidal force or the pole fling force are mainly responsible for the movement of tectonic plates, but this cannot be possible. Tidal force is very weak, and with the help of the tidal force tectonic plates can't move. So after this continental drift theory, other theories came which also contributed to the plate tectonic theory. So in around 1928, the theory was proposed, convection theory. This was proposed by the Arthur Holmes, and he says that the convection currents in the asthenosphere layer is mainly responsible for the movement of the tectonic plates. He say, see, this is the structure of Earth, internal structure of Earth. We know core is there here, and in the core the temperature is somewhere around 4000 to 5000 degrees Celsius. And the asthenosphere layer is there, middle part of the mantle, and we know that it is semi-solid or semi-liquid in state. So what is happening, due to the presence of the radioactive element, high temperature is there, and due to this convection currents in developing in the asthenosphere layer. So what is convection currents? You know it very well. When the liquid get heated, the liquid molecule moves from high energy area towards the low energy area. Same as you have seen the example of the boiling of milk. When we boil milk, the milk rises upward. Why it is rising upward? Because it is carrying the heat from the high energy area towards the low energy area. This is convection current. So he says that in the convection theory, it was proposed that the convection currents developed in the asthenosphere layer, and this movement of the convection current, the magma is rising upward. At the upper parts, the Earth's temperature is low, so magma cool down, and again it falls downwards. So this is how continuously cyclical movement of the magma is taking place in asthenosphere, and those tectonic plates which are floating over the asthenosphere layer, they also move along with the magma. Okay, so this was like here, magma is moving in this direction, the plates will also move in this direction. So he says, Arthur Holmes, he says that the convection currents is mainly responsible for the movement of tectonic plates. However, after the Second World War, during Second World War, submarines were used, and it has been observed that ocean floor is not simply plain floor, but it comprises of many distinct relief features. So ocean floor mapping was done, and new informations were collected from the ocean floor. See, up till now what happened, Wagner collected all the information from the land masses. So later on scientists said, let's let's collect this information and try to search the reason how the continents and the oceans developed. So first of all, ocean floor mapping was done during the post World War, Second World War. So when the ocean floor mapping was done, so what has been observed? Major things that has been observed is ocean floor is not just a plain, many distinct relief. What sort of relief features? Mid-oceanic ridges were found, trenches were found, sea mounts were there, Guyots were there. So many were such things were observed in the sea oceans. Then they observed the age of the oceanic crust. That is very young in comparison to the continental crust. They observed that ocean crust is hardly 200 million years ago. However, the continental crust, that is somewhere around 3200 million years ago. So this again proves that oceanic crust is new, and the continental crust is very old. They also observed one more thing: sediments deposition in the oceanic crust is very less in comparison to the continental crust. What they observed in oceanic crust, the depth of the sediment deposition is hardly 7 to 8 kilometers, while in the continental crust it is somewhere around 30 to 40 kilometers. So this again further proves that oceanic crust is new. See, what is being observed, suppose this is the earth surface, okay, and here this is continental crust, and this is also a continental crust. In between, this is the oceanic crust. So what they observed in the ocean floor, ridges in the middle part of the ocean, this is ridge. These are the ridge is what? Such mountains whose average height is less than 1000 meters. So such sort of ridges were found in the ocean floor. Okay, then what they observed, the deposition of sediment is very less close to the ridges, and as we are moving away from the ridge toward the continental crust, the thickness of the sediment is increasing. This thing was also observed while ocean floor mapping. Then what they observed, the rocks which are at equidistant from the ridges, they have the similarities. What sort of similarities were found? Those rocks, suppose one rock part is here, so at equal distance the another rock part is here. So what is being observed, these both rock has the similarity. What sort of similarities was there? They are of the same age, their chemical properties were same, the fossils which were found in these rocks were same, their magnetic properties were same. So all this thing together proves that at some point of time this landmass and this landmass was combined together. Later on it splitted and moved away from each other. It means sea floor is spreading. Is it clear? So this was being observed while ocean floor mapping was done. So these evidences were later on proved by the one other theory. Its name is seafloor spreading. So around 1961, one theory came, seafloor spreading, and this theory tries to explain seafloor spreading. This seafloor spreading this theory was proposed by Hess, and Hess tried to explain what is being observed during ocean floor mapping. So Hess says that continuously, like this is the core of the earth, so because of the radioactive elements, temperature is high, so continuously lava, convection currents are developing in the magma, and lava is continuously rising upward. In the ocean floor, ocean crust is thin in comparison to the continental crust. This is the reason it is easier for the magma to come out on the earth's surface through the oceanic crust. So that point where the ridges are located just above the rising limb of the convection currents. And when the convection currents, the lava is coming out of through the ridges, and the lava is depositing on both the side of the ridge, and a new oceanic crust is forming. So this is how continuously construction of a new crust, oceanic crust, occurs near the ridges. And what is happening now? The lava cools down, so it starts subducting downwards. So this is the descending limb of the convection current. This is how I told you earlier also, the convection theory, what is happening continuously, magma is heating, it is rising upward, cooling down, and again it is falling downwards. This is how cyclical process is continuously going on in the asthenosphere layer. So at the rising limb, ridges are forming. And what is happening at the descending limb? At the descending limb, the oceanic crust is subducting under the continental crust. What is happening here? Because you know that continental crust is lighter than the oceanic crust. As we discussed earlier, continental crust is mainly made up of silicon and aluminium. So Cl, oceanic crust is mainly made up of silicon and magnesium, CMa, and the oceanic crust is heavier than the continental crust. This is the reason what is happening. The oceanic crust start subducting under the continental crust, and that point where it starts subducting, trenches are formed. So here what is forming? Trenches. At ascending limb, the ridges are forming, descending limb, trenches are forming. This was proposed by the Hess in the seafloor spreading. So what he is saying, that since continuous upwelling of the lava is taking place at the ridges, and the lava is depositing on both the side of the ridge, so new oceanic crust is forming and sea floor is continuously spreading. So this is the reason he named this theory as sea floor spreading. However, the sea floor spreading was further proved by the Matthew when he studied the magnetic properties in 1965. He explained with the help of the PALEOMAGNETISM, he explained this thing, seafloor magnetism. He explained that the seafloor spreading has taken place. What he observed, he studied the magnetic properties of the minerals which are found in the rocks, the rocks which are at the equal distance. So he found the zebra-like pattern. The alternate, the band one strip of normal polarity. You know that when the rock form, it is in the lava comes out, it is in the molten state, and later on it solidifies. So molecules align themselves along according to the Earth's magnetic field at that time. So what they observed, suppose this is a ridge and the rocks is here. So both the side it observed the zebra-like pattern. Zebra-like pattern means here he found North Pole, South Pole. So adjoining band will be of reverse polarity. South Pole, North Pole. Again North Pole, South Pole. Here the same pattern is being observed. So those rocks which are at equidistance, they have similar magnetic properties. This is known as magnetic stripping. So this further proves that sea floor spreading is taking place. So all these concepts were combined together to explain the movement of the tectonic plates in the plate tectonic theory. So now we will discuss what is being explained through the plate tectonic theory. So around 1967, this plate tectonic theory came. All these theories' aim is to solve the mystery of the formation of the continents and the ocean. So now let's discuss in detail plate tectonic theory. Okay. The plate tectonic theory, this was mainly given by, the main contribution was of Morgan. Although the word plate tectonic was used first by the Wilson, however, major contribution was by Morgan, Parker and Mackenzie. They proposed this plate tectonic theory. The word plate tectonic, plates are the what? These are the slabs, irregular, huge size slabs of the lithosphere. As we discussed earlier, when we discussed about the internal structure of Earth, that time I told you that the upper part of the Earth, suppose this is the interior part of the Earth. Earth is divided into 3 layers: crust, mantle and core. So this part, the outermost part is the thinnest one. So this is the core, crust, mantle, core. Outermost layer is crust, mantle and core, and the middle part of mantle is what? Asthenosphere, semi-solid and semi-liquid in state. Okay, so when it means the solid part of the Earth is this much. It includes what? Crust and upper solid part of mantle. This is what we call as lithosphere. This includes what? Crust plus upper solid part of mantle. If we see the size of the Earth, you know that radius of Earth is somewhere around 6,400 kilometers. In this comparison, lithosphere is very thin, hardly 100 kilometers. Where the ocean is there, or where continents is there, maximum 200 kilometers. So in comparison to the size of the Earth, lithosphere is very thin. Therefore, it is broken up into pieces. These pieces are known as tectonic plates, and these tectonic plates are floating over the asthenosphere layer. The word tectonic activity, it means all those activities which is related to the bending, breaking, construction and the formation of the lithosphere. This whole lithosphere presently, it is divided into seven major tectonic plates and 20 minor tectonic plates. These tectonic plates can be either completely continental crust or completely oceanic crust, like Pacific plate is completely oceanic plate. And if you see the Eurasian plate is what? Continental plate. And it can be so, a tectonic plate can be partly continental and partly oceanic. For example, Indian plate, its half part is has continental crust, while its half part has the oceanic crust. Okay. Then next, the plate boundary. See, suppose these are the two plates. So on the basis of the relative motion, that part of the plate where the plate is either moving away towards from each other or coming close to each other, any sort of relative movement is there. So that part of the plate is known as plate boundary. Is it clear? So according to the plate tectonic theory, there are 3 types of plate boundaries. 3 types of plate boundaries. See, what can happen? We know this thing very well, that the plates horizontal movement is taking place. So what is the possibility? Either 2 plates are coming close to each other. So this type of movement is what? Convergent movement. Or this can be possible, 2 plates are moving away from each other. So this is what? Divergent movement. Third case, the 2 plates are neither moving away from each other nor coming close to each other. They are just sliding past each other. So this type of boundary is what? Transform boundary. So first is convergent boundary. also known as, we can also say this as destructive boundary, because destruction takes place wherever destructive boundary. So wherever two plates strike with each other, destruction takes place. So in this, what is happening? Two tectonic plates are coming close to each other. Okay. Then second case is divergent boundary. Divergent boundary, this is also we can say it as a constructive boundary, because construction is taking place. As recently we discussed seafloor spreading, at ridges two plates are moving away and lava, continuous upwelling of lava is taking place and new oceanic crust is forming. So what is happening? Construction is going on where the divergence of the two tectonic plate is taking place. So in this, what is happening? Two plates are moving away from each other. Okay. And the third case is transform boundary. So in the case of transform boundary, what is happening? Two plates are neither moving away from each other nor coming close to each other. They are just sliding with each other. So this is the third boundary. Now we will take each and every case separately and we will discuss what is happening in each case, what relief features is forming or what phenomena is taking place on the Earth's surface. So now let's first discuss about the convergent boundary. So when we are discussing about the convergent boundary, when I am saying two plates are sliding with each other, it means what? Two plates are striking with each other. So in this case, three possibilities are there. First, either one continental plate is striking with the oceanic plate, or it can be the possibility one continental plate is striking with the another continental plate, second case. And third case is when one oceanic plate is striking with the other oceanic plate. So here three possibility is there. When I am writing CP, continental crust, is striking continental plate, CP is the continental plate, is striking with what? Oceanic plate. Second case, when the continental plate is striking with the second continent with the another continental plate. And the third case is when the oceanic plate is striking with the another oceanic plate. Okay, so there are three possibilities. Now let's discuss these cases one by one. Now let's first case. The first case is when continental plate is striking with the oceanic plate. So what is happening in this case? You know that continental plate is lighter because it is made up of Cl, and oceanic plate is denser because it is made up of Cma, silicon and magnesium. So what is happening? When the two plates strike with each other, the oceanic plate, because it is heavier, it starts subducting under the continental plate. And when it starts subducting under the continental plate, due to high temperature, this part of the oceanic plate will start melting and it will convert into lava. So here what is happening? Suppose this is the continental plate and this is the oceanic plate. So what will happen? This oceanic plate slowly and slowly will start subducting under the continental plate. We cannot see such type of movements because all this movement is occurring below the water. Now this part where the oceanic plate is subducting under the continental plate, this start melting, it will convert into lava. So what will happen? This part, the margin of the continental plate, boundary of the continental plate, oceanic boundary of the continent, in this area, wherever the rocks are weak, this magma will start will try to come on the Earth's surface. Upwelling will take place, magma will come, and what will happen? On Earth's surface, volcanic eruptions will take place. If the volcanic eruption is on the continental plate, volcanic mountain will form. If this eruption takes place on the oceanic crust, so sea mounts can form. And if the height of the sea mount increases and it comes above the sea level, so here you can see a small land mass. It means island is forming. So this is how islands are formed. So it means what are the features that are forming when the continental plate is striking with the oceanic plate? First, volcanic mountains are forming, or sea mounts are forming, or islands are forming. So I am writing it here. What are forming? First is volcanic mountains are forming, right? Then islands are forming. And that point where the oceanic plate starts subducting under the continental plate, here a narrow depression forms, and this is known as trench. It means trenches will form at that point where the oceanic plate is subducting under the continental plate. See, this part is known as where the margin of the continental and the oceanic plate, this is known as subduction zone. This is also known as Benioff zone. So it means this zone is more prone for the volcanic eruption. This zone is more prone for the earthquake. This zone is more prone for the formations of the fold mountains. When the two plates will strike, since continental plate is lighter, so what will happen? Folding will take place. So what is happening? This margin, this boundary of the continental plate will start folding, and the fold mountains will form. So fold mountains will also form. So these are the major things, 4 major things: volcanic mountains, islands, trenches, and the fold mountains will form in those areas where the continental plate is striking with the oceanic plate. Is it clear? Now let's take an example where this thing is happening on Earth. You know that Pacific Ocean is the largest ocean, and the whole ocean is on a plate, and that plate is what? Pacific plate. I'm making just a rough diagram to explain you. Suppose this is Asia, and you know that Asia is on a plate. Its name is Eurasian plate. So this is which type of plate? Continental plate. Here it is Australia, and you know that Australian plate, Indo-Australian plate. So this is also a continental plate. Then comes the Pacific Ocean. Whole Pacific Ocean is on the Pacific plate. So this is a type of oceanic plate. Then comes here, this is America, okay, and North American plate and the South American plate. So this American plate is again what? A type of continental plate. So this is the case what we are discussing right now. Here what is happening? An oceanic plate is striking with a continental plate. See, so what is happening at this margin surrounding the Pacific Ocean? The Pacific plate is continuously subducting under the continental plate, and this is the reason it is continuously converting into magma. So this zone is the subduction zone or the Benioff zone. This is the reason world's maximum volcanic eruption, almost 80% volcanic eruption is taking place in this region, and this is the reason we call this zone as a ring of fire, because maximum volcanic eruptions are taking place in this region. When you see the world map, Pacific Ocean map, you will find thousands of islands in these areas. So most of these islands are volcanic in nature. So many times, this is one of the favorite question of the examiner. Many times it comes in the IS mains exam, why the maximum volcanic eruptions or maximum earthquake come in this region, or why the maximum islands are present in this area. So the plate tectonic theory successfully explain this phenomena here. So if you see here, this is Indonesia. You might have heard about the Mount Krakatoa. So this is a dormant volcano in Indonesia. This is here. You know that Japan. And now you got it. Why the maximum earthquake comes in this region? Because this is a convergence zone. Here two plates are striking with each other. You might have heard about the Mount Fujiyama. It's an active volcano in Japan. So again, it is located here. You might have heard about Hawaii Island. Again, it is volcanic in nature. So why, question as why maximum volcanic eruption is here? Our answer is what? Continental plate is striking with the oceanic plate. Again, we discussed earlier that maximum number of trenches are in Pacific Ocean. We heard about the Mariana Trench. You know, Philippines is here. In Philippines also there is a volcano, Mount Mayon. It is in Philippines. Again volcano. And here you found a trench, Mariana Trench, which is the deepest trench of the world. And maximum number of trenches are in Pacific Ocean. So again the question is why maximum trenches in the Pacific Ocean? Again our answer is same. Oceanic plate is striking with the continental plate. Then see what sort of movement is taking place. This American plate is hitting the Pacific plate and Pacific plate is hitting the Eurasian plate. Means westward movement is taking place. And when these plates moves westward, so their west margins gets folded. So what happened when the west margin of the North American plate folded? It gave rise to the formation of Rockies. You might have heard about the Rockies mountain range, and it's a Southern American west margin folded. This gave rise to the Andes. So is it clear why the Rockies formed? Why the Andes formed? These all are what? Types of the fold mountains. Why it get folded? Because these plates are moving towards the west. And in these fold mountains, volcanic eruption will also take place because oceanic plate is subducting under the continental plate. If you see in America, there is a Mount Rainier. So it's a type of volcano. Again, you might have heard about Mount Cotopaxi. Again, it is a volcano. You might have heard about Ojos del Salado. This is the highest active volcano. So again, so many questions. Answer is one. Oceanic plate is striking with the continental plate. Again, see here also thrust. The Australian plate also felt the thrust. So its eastern part gets folded, and here that fold mountain form is the Great Dividing Range. So hope it is clear, the whole picture is clear, why maximum volcanic eruption is taking place in this region, why maximum earthquake comes in this region, why large number of islands are forming in this region, why Rockies, Andes, the long fold mountain ranges are formed in this region. The answer is oceanic plate is striking with the continental plate. So we have discussed first case. What we are discussing? Movements of the tectonic plate. First is convergent movement, second is divergent movement, third is transform movement. So right now we discussed about the convergent movement first case, when continental plate is striking with the oceanic plate. Other cases are also there that we will discuss in next class. Hope your all doubts are clear. If you have any problem, then you can ask me. So rest we will continue in our next lecture. Thank you so much.